Okay, Y11, welcome to the last part of this revision videos on Physics Paper 2 2024. Again, please grab your whiteboard and your whiteboard pen and please answer this question. Please take about 2 minutes. Yeah, 2 minutes to do this. Please pause the video. Okay, so let's check your answer. Frequency, which is the number of waves passing by per second, is measured in hertz, capital H, lowercase z. Speed, which is how fast the wave is going, is measured in meters per second. The wavelength is measured in meters. The time in physics is always measured in seconds. The mass in physics is measured in kilograms. The energy is measured in joules. Forces are measured in Newton, capital N, and any length or distance is measured in meters. Okay, on your test, please answer question 6. Please pause the video for 5 minutes. Guys, try really hard to answer all these questions. Let's go, 5 minutes. Please pause. All right, welcome back. Get your green pen. Let's go through the answers together. So here we have a pretty crazy equipment, but teacher demonstrated how the frequency of a wave on a string affects the wavelengths of the wave. So they have a signal generator, which is going to send message to the vibration generator, which is going to make the string vibrate. The string is attached to masses, and the string is there then going to vibrate. You also have a meter rule in order to measure the wavelengths. The frequency of the signal generator is adjusted so that the wave shown in figure 11 is seen. So you have a full wave like that. At this frequency, the string vibrates between the two positions shown in figure 1. So they go up and down, up and down. Describe a method the teacher could use to investigate how the frequency of the wave affects the wavelengths. So what they're going to do is use the signal generator to adjust the frequency. Okay, the vibration generator is going to change how quickly or slowly it goes up and down. You want to keep the number of masses the same, and you want to slightly move the wooden bridge to obtain nice waves. At some point, you're going to observe a steady or stationary wave pattern. Okay, so even though it's moving, it appears like it's not. Then you're going to use the meter rule to measure the wavelengths of your wave. So two identical points of successive waves, and you're going to repeat that using different values of frequency. Okay, and you're going to repeat that for different stationary wave patterns as well. So take 2 minutes to write this answer down. We unfortunately cannot do that in school. We don't have the equipment, I think, but you kind of need to know that apparently. Question 6.2. Using the physics equation sheet, which equation links frequency, wavelengths, and wave speed? So this one is given. The velocity of the wave or the speed of the wave equal the frequency times the wavelength. Remember, the speed of the wave is measured in meters per second, the frequency in hertz, and the wavelength in meters. The wave on the string has a frequency of 45 hertz. The wave speed is 35.1 meters per second. Calculate the wavelength of the wave. So, formula, speed equals frequency times wavelength. Insert value. The velocity or the speed is 35.1 meters per second. That's the correct unit. We don't need to convert it. The frequency is 45 hertz. We don't have to convert it. And the wavelength is what we're looking for. Fine tune, we're going to make wavelength the subject of the equation by dividing both sides by 45. And the answer is therefore 0.78 meters. Okay, we're about to do the last bit, all about energy. On your mini whiteboard, take 2 minutes to tell me what is meant by the law of conservation of energy and what energy store can you remember. Please pause the video for 2 minutes. Okay, so the conservation of energy means that during an event, the energy cannot be lost or produced. It's transferred between energy stores. And the energy store that you need to remember are, for example, the thermal energy store when an object is hot, kinetic energy store when an object is moving, gravitational potential energy store when an object is high in the air, elastic potential energy when an elastic is either stretched or compressed. What else do we have? Oh, we have a few. I can't remember them all. Anyway, those are pretty much the most important one you need to remember. Finally, 5 minutes to do question 7. Please pause the video. Okay, let's go get your green pen. Let's go through all the answer of question 7 together. Make sure we're down the correct answer to the one you go wrong. So figure 2 shows an Olympic gymnast performing a floor routine. The floor contains springs. When a gymnast lands on the floor, a force compresses the springs in the floor. They're getting elastic potential energy. When a spring is compressed, the elastic potential energy of the spring increases. Explain why compressing the springs in the floor helps the gymnast to jump higher. Use ideas about energy in your answer. So as the spring decompresses, so when it comes back to its original length, the elastic potential energy of the spring decreases, and it is transferred to the gymnast. Because as the gymnast leaves the floor, the kinetic energy of the gymnast increases, they move faster, or the gravitational potential energy of the gymnast increases. So the elastic potential energy of the spring is transferred into the kinetic energy store of the gymnast, or their gravitational potential energy store. 7.2. When a gymnast lands on the floor, one of the springs compressed by 1.2 centimeter. Spring constant is 8,500 Newton per meter. Straight away you can see there is danger here. The extension or the compression is given in centimeter. You have to convert it in meters. So remember there is 100 centimeter in a meter. So 1.2 centimeter, you have to divide by 100 to find it in meters. And the extension is 0.012 meters. Then the formula is energy equals 0.5 times the spring constant times the extension squared. Replaced by the value, energy equals 0.5 times 8,500 times 0.012 squared. Don't forget to type the squared. You don't need to do any fine tune. You have the right subject. All the values are in the right unit. So you find an answer of 0.612 joules. Okay, don't forget, all the energies are measured in joules. The student investigated a spring with a different spring constant. When masses are placed on the spring, it compresses. The student measured the compression of the spring for different masses. Figure 13 shows some of the equipment used. Describe how the compression of the spring could be determined. So first, you're going to measure the original length of the spring and the compressed length of the spring using a meter rule. And the compression equals the original length minus the compressed length. Okay, so if your spring is 5 centimeter long without any mass on it, then when you compress it, it becomes 2 centimeter long. The compression is 5 minus 2, 3 centimeters. Explain why the investigation should be done on the laboratory floor rather than on a table. The mass could fall off the spring. Okay, so if it falls, it's better if you're doing it on the floor than on the table, because otherwise you may have the masses falling on your foot and get injured. So the mass could fall. It is less likely to cause harm injury if the investigation is done on the laboratory floor. Last question, I think. Yes. So we have this graph showing the compression, or the force in Newton, depending on the compression in meters. Determine the value delta Y on the graph. So I showed my work for you. So the top of Y here is 330. The bottom is 80. So to calculate delta Y, you do 330 minus 80, which is 250 Newton. The delta X, I'm going to do the exact same thing, is going to be 0.052 minus 0.01, which is 0.042 meters. And question 7.7, determine the spring constant of the spring. So you have to use the equation K equal delta Y over delta X, so the change in force over the change in distance. So 250 divided by 0.042, which is 5,952.38. And to three significant figures, it's 5,950 Newton per meter. Okay, this is it for me. Hope you enjoyed that. Make sure you have all the correct answer. Feel free to ask Miss or Sir to replay the part of the video that you need. Good luck with your revision, and I will see you very shortly. Bye guys, stay amazing.